All right, you're gonna want to pay attention to this. Nvidia just dropped something that could seriously change how we use AI, on our own devices. It's called Nemotron Nano 2, and it's a massive, massive leap forward in making powerful AI incredibly efficient. Just look at that. 6 times. That's not some tiny little improvement we see every year. That is a gigantic jump in performance. So in this explainer, we are going to break down exactly what that number means. And the really cool part, how on earth Nvidia pulled it off. So yeah, this is the big question, right? And it's not just about making things faster for the fun of it. This is about unlocking a whole new kind of AI that can actually think, that can reason through huge amounts of information, but without needing a warehouse full of computers to do it. To really get why this is such a breakthrough, we have to talk about the problem first. See, for years, the undisputed champ of large language models has been the transformer architecture. It's the engine behind basically every big AI you've ever heard of. But it has a secret. A very, very expensive secret. So the magic behind the transformer is this thing called self-attention, and it's kind of a brute force approach. To understand what a sentence means, the model literally compares every single word or token to every single other token in the text. It gives the AI an amazing understanding of language, but it creates a huge, huge computational bill that just doesn't scale well. And this is where that scaling problem just smacks you in the face. If you give a transformer 1,000 tokens, it makes 1,000,000 comparisons. Okay, that's doable. But if you just 10x that input to 10,000 tokens, the work doesn't go up by 10x. It explodes by 100x to 100 million comparisons. They call this quadratic scaling, and for computers, it is an absolute nightmare. Visually, the difference is just, whoa. With linear growth, which is what you want, 10 times the input means 10 times the work. Simple. But with quadratic growth, that same 10x input costs you 100x the work. This is the wall that transformers are slamming into. It's what makes it so slow and expensive to have an AI read a long book or a big chunk of code. So when the reigning champion hits a wall, it's time for a new contender, right? Well, meet Mamba. And Mamba is clever. It doesn't try to punch through the wall. It just walks around it with a totally different way of thinking about information. This is the absolute best way to understand the difference. A transformer is like a person who, for every new word they read, has to go all the way back to the beginning and reread the entire book up to that point. It's thorough, but it's completely exhausting. Mamba, on the other hand, just reads, like we do. It keeps a little summary in its head of what it's read so far, and it just updates that summary as it goes. The official term for this is a selective state space model, or SSM. And that word, selective, is everything. Just like your brain, it's designed to remember the important stuff, the plot twists, the key characters, and let go of the trivial details from way back in Chapter 1. This keeps its memory efficient and not bloated with useless info. And the payoff for this approach is exactly what we were looking for. Because Mamba just reads in a straight line, its cost scales linearly. 10 times the text costs 10 times the resources. We've completely flattened that explosive, scary curve into a predictable, manageable straight line. Okay, so you're probably thinking, great, Mamba is the new king, Transformer is out, but that's not what Nvidia did. They were smarter than that. They realized that while Mamba is incredibly efficient, that old brute force attention thing Transformers do is still the absolute best at one very specific job. The real genius here is how they teamed them up. So the design for Nemotron Nano 2 isn't some 50-50 split. No, it is overwhelmingly built with these super efficient Mamba layers. But tucked inside that structure, that's where they put the secret weapon. A little strategic dose of the old champion's power. Okay, so here's how it works. You've got the Mamba layers just cruising through the text, processing it super fast. But then, every so often, the data hits what Nvidia calls an attention island. That's a classic transformer layer that stops the linear reading for a second to get a bird's eye view, connecting ideas from totally different parts of the text. Then the Mamba layers take over again, but now they're smarter, armed with that deep, long-range context. And check this out. This is the actual blueprint from their research. You can see these attention blocks are sprinkled in very, very carefully throughout the model. They only make up about 8% of the total layers. Mamba does all the heavy lifting, but these few, powerful attention layers give the model the superpower to connect a detail in Chapter 1 with a question asked in Chapter 20. That's a trick pure Mamba would really struggle with. So we have the blueprint, the recipe. But, building this thing wasn't just about duct taping two technologies together. It was a really sophisticated piece of engineering to find the absolute perfect, most efficient balance. Just look at that split. It is so Mamba dominant. 92% of its brain is for that efficient, straight-line processing. Only a tiny 8% slice is for that super expensive but super important self-attention. It's all about getting the maximum possible bang for the absolute minimum computational buck. And that 92 to 8 split, they didn't just guess that. Nvidia used a wild technique called neural architecture search, where they essentially had another AI run countless experiments to find the perfect design. They started with a big 12 billion parameter model and had the AI intelligently shrink it down to a hyper-efficient 9 billion parameter model that kept the smarts but ditched the waste. Okay, so we've seen the problem, we've seen the clever new design, and the engineering that made it real. So now for the fun part. Let's look at the results. What does this new horizon of efficient AI actually mean in the real world? All of this work, all this cleverness, it all comes together to create something that really does feel like a new era. An era of AI that's powerful enough to be useful, but efficient enough that it doesn't have to live in a giant data center. And here it is, the money shot. Remember that 6x from the beginning? Well, compared to a state-of-the-art transformer-only model of a similar size, Nemotron Nano 2 gets up to 6.3 times higher throughput. That means it can generate long, complex answers over 6 times faster. It's the direct result of that smarter design. So let's just recap the big wins here. You get that massive speed boost. You get the ability to process enormous 128,000 token contexts. That's like a whole novel in one go. And here's the kicker. It can do all this on a single, pretty accessible Nvidia GPU. It even has this cool feature that lets you set a thinking budget, so its performance is always predictable and real-time. And look, this is the bottom line. This is the why you should care part. This breakthrough means that truly powerful AI that can reason through complex legal documents or debug code, can now actually run locally on devices we use every single day. We're moving from an era of just cloud AI to an era of powerful, personal, and private AI. Which really leaves us with this final question, doesn't it? For the last few years, the whole race has been about who can build the biggest, most colossal model. But Nemotron Nano 2 points to a different path. Maybe the future of AI isn't just about building bigger, maybe it's about building smarter.